There's a single machine on this planet that makes modern civilization possible. Your phone, your laptop, AI data centers, fighter jets, satellites, all of it runs on chips that could not exist without this one piece of equipment. It is made by a Dutch company called ASML, and for years the West's entire semiconductor advantage over China came down to the fact that China simply could not get one. That may have just changed. In December 2025, Reuters dropped a bombshell report. China has built a working EUL lithography prototype in Shenzhen right now, already generating extreme ultraviolet light. Built largely by former ASML engineers, some of whom were reportedly hired under false identities and working in sealed facilities with the kind of secrecy you'd expect from a nuclear program. This is not a rumor. This is not propaganda from Beijing. This is Reuters, citing multiple sources on the ground. And if you understand what the UV lithography actually is, you understand why this matters so much. Let me give you the quick version of why ASML's machines are genuinely one of the most complex objects ever built by humans. An EUV machine works by firing a high-powered CO2 laser at tiny tin droplets, about 50,000 times per second, creating plasma that releases extreme ultraviolet light at a wavelength of 13.5 nanometers. That light gets bounced off ultra-precise mirrors made by a German company called Zeiss, mirrors so smooth that if you scale them up to the size of Germany, the biggest bump would be about a centimeter tall. The light then etches circuit patterns onto silicon wafers, printing features smaller than a strand of DNA. One machine weighs as much as a commercial aircraft and takes up most of a factory floor while costing around $400 million, and it contains over 100,000 individual components sourced from suppliers across dozens of countries. ASML has been developing this since the 1990s. That's not a product, that's an entire civilization of engineering compressed into a single box, and China has been completely locked out of it. Not one single EUV machine has ever been sold to a Chinese company thanks to export control coordinates between the US, Netherlands, and Japan. For years, analysts said China was at least a decade away from replicating this independently. Some said it was simply not possible. Now here's what people often miss. China did not sit around waiting. They adapted. SMIC, China's top chip foundry, figured out how to reach 7 nanometer node chips using older DUV machines and a technique called multiple patterning, essentially exposing the same wafer to light multiple times at different angles to simulate finer resolution. To reach 5 nanometer, they needed to do this for separate times. Every extra exposure step multiplies the chance of alignment errors. The yield rate on their 7 nanometer process has ranged from a dismal 20% at launch to somewhere around 40% by early 2025. Now compare that to TSMC, which hit 93.5% yield on a 7 nanometer back in 2019. And the cost of doing all this, about 50% higher per chip than if they had an EUV. So yes, China is making advanced chips. Huawei's Kirin processors are in phones and laptops right now. The Ascend 910C AI chip is shipping, but doing it without EUV is like building a skyscraper using hand tools instead of cranes. You can do it. It just takes longer, costs more, and the results are less reliable. That is the ceiling China has been hitting, and that ceiling, frankly, is why the EUV prototype is such a massive development. So let's talk about what Reuters actually found. The prototype was completed in early 2025. It sits inside a high-security facility overseen by China's Central Science and Technology Commission and occupies nearly an entire factory floor. The team behind it includes former ASML engineers, some recruited as far back as 2019, with signing bonuses reportedly between $420,000 and $700,000 US, plus housing subsidized. One of the key key features mentioned in the report is Lin Nan, ASML's former head of light source technology, whose team at the Shanghai Institute of Optics has filled 8 EUV light source patents in just the past 18 months. The machine can generate EUV light. That is the hardest part. It has not yet produced working chips, but the light source works. Parts of the prototype were reportedly sourced by purchasing old ASML machines on the secondary market and reverse engineering components with purchases routed through middlemen to hide the trail. Huawei, according to Reuters report, is playing a central coordination role, linking a nationwide network of companies and state research institutes with thousands of engineers involved. This is essentially a Manhattan Project for semiconductors. Now, ASML's own CEO, Christophe Fouquet, said in April 2025 that China would need many years to develop this, and technically he's not wrong. The prototype is roughly comparable to where ASML itself was around 2001 to 2010, capable of generating the light, not yet capable of mass-producing chips at commercial scale. China's target for producing actual chips using this machine is 2028, though most experts consider 2030 more realistic. But here's what I find genuinely impressive about all this. The timeline compression is real. People said it was impossible, and they said it was 20 years away at least, and now we're looking at maybe 5 years. That deserves respect, even if you disagree with Beijing politics. Now, the prototype is the headline, but China is also betting on completely different approaches to the problem, and some of them are actually fascinating. Huawei's facility in Dongguan has been testing something called laser-induced discharge plasma, or LDP. ASML uses CO2 lasers to vaporize tin droplets. The LDP method instead vaporizes liquid thin between electrodes using high-voltage discharge. Different physics, different engineering challenges, but the same result. Researchers working on a related approach using solid-state lasers have reportedly achieved a 3.42% conversion efficiency, which is getting close to practical territory. ASML abandoned solid-state lasers years ago because of efficiency problems, so China is essentially trying to solve a problem ASML already decided was too hard. Whether that ends up being a dead end or a genuine shortcut remains to be seen. Then there is the nano-imprint lithography, or NIL. Canon in Japan already has commercial NIL machines, and they are interesting because instead of burning patterns with light, you physically stamp them onto the wafer, like a high-tech rubber stamp. Cheaper, more efficient, no need for insane laser systems. The trade-off, however, is that it's slower and it works better for memory chips like NAND and DRAM rather than for complex logic chips and AI processors. China's company Pre-Nano is developing NIL machines specifically for memory applications. YMTC, China's memory chip maker, has already made remarkable progress with the 3D NAND technology. NIL could accelerate that further. And then there's the C-Carrier, a company founded in 2022 that showed up at SEMICON China in early 2025 and unveiled an entire suite of wafer fab tools, etching, deposition, epitaxy, essentially attempting to build a full domestic fab equipment stack from scratch. The company is barely 3 years old and is already making serious noise. While all this is happening, the US is not just watching. In December 2025, the Trump administration signed a letter of intent to inject up to $150 million into a startup called X-Light. The company is developing a free electron laser for chip manufacturing, technology derived from particle accelerators built in partnership with the US National Laboratories. Former Intel CEO Pat Gelsinger joined as executive chairman and said that the system could improve wafer processing efficiency by 30 to 40% compared to the current EUV. The target wavelength is 2 nanometers compared to ASML's 13.5. If X-Light delivers on that, it would not just maintain the West's lead, it would extend it significantly. Gelsinger's exact quote was, "We're here to wake up Moore's Law. It's been taking a nap." That is the kind of energy this moment calls for. Look, I think there's a tendency here in the Western tech media to either massively underestimate China or overreact every time there's a breakthrough. Both are a mistake. So here are my thoughts. China has done something genuinely impressive, getting EUV light out of a domestically built prototype after being completely locked out of the global supply chain after sanctions, after the recruitment restrictions. That is a real engineering achievement. The people behind this are not getting nearly enough credit. But a prototype that generates light is not a mass production machine. ASML took decades and the combined expertise of an entire global supply chain to get where it is. China is rebuilding that from scratch with second-hand parts, under sanctions, and without access to Zeiss optics, which remains the single hardest unsolved problem in the entire effort. The mirrors alone might hold things back for years. What I find most interesting is that this race is no longer about whether China can do it. It is about whether the West can stay far enough ahead so that the gap still matters strategically. And right now, between X-Light's free electron laser work, ASML's own roadmap pushing toward even higher NA-EUV systems, and new approaches like helium atom beam lithography quietly being developed in the background, the finish line keeps moving forward, away from China. China is running faster than anyone expected, no doubts there, but the track keeps getting longer. This is the defining industrial competition of our lifetime. Chips are not just consumer electronics, they're military hardware, AI infrastructure, and economic leverage all at once. And right now, for the first time ever, both sides are genuinely racing. I would not say game over for China, but I wouldn't say game over for the West either. What I will say is, this just got a lot more interesting.